For today's lesson, we will look at an example of how energy is gained and lost during chemical reactions, and we will explore how catalysts can affect reaction rates. This question asks you to draw a potential energy diagram for the reaction between carbon monoxide and nitrogen dioxide. The question gives values for the activation energy and the change in enthalpy for the reaction. Because the question gives a value for the activation energy, your potential energy diagram should show a peak energy between the reactants and products. Since the change in enthalpy of reaction is negative, the reaction is exothermic. Here is the diagram that shows the energy pathway for the reaction. Notice that the potential energy diagram still shows the reactants and products, but also shows a high energy transition state. The activation energy that is given in the question is used to label the difference between the reactant's energy level and the energy level of the activated complex. The change in enthalpy of reaction is the energy difference between the reactants and the products. The final part of the question asks what the activation energy of the reverse reaction would be. For the reverse reaction, imagine that the entire reaction pathway is reversed. If you were moving backwards from the products, you would see that the energy required to reach the activated complex energy level would be the sum of the activation energy and the enthalpy change of reaction. These diagrams show how the activation energy is shown in both endothermic and exothermic reactions. Notice that there is a bump to signify the higher energy activated complex right in the middle. The main difference between the two potential energy diagrams is the difference between the energy levels of the reactants and products. A principle that we have used previously in applying Hess's law has to do with bond energy. Energy is required to break chemical bonds, and energy is released when new chemical bonds are formed. The amount of energy released and required is what gives the enthalpy change of reaction. A catalyst is something that can be used to increase the rate of reaction. It is not considered a reactant because it is not used up in the reaction. Catalysts work because they provide an alternative, lower energy pathway from the reactants to the products. In biology, we call catalysts enzymes. This diagram shows how the potential energy diagram is changed when a catalyst is used. The only part of the potential energy diagram that is changed is the activation energy, or the size of the energy peak of the transition state. Notice how the net enthalpy of the reaction remains unchanged. Why do you think this is? Because the reaction has exactly the same reactants and products. All finished. This is the final lesson of your thermochemistry unit. You will have a few days off from watching videos so that you can prepare for your unit exam.